This is a 2013 Kia Optima, and the system's now running and stabilized in a relatively low heat load condition. So we're going to take a look at what the PCM is commanding the compressor to do and compare that to our gauge pressure readings. On the bottom left we have a tool that's displaying about 41% duty cycle, and next to that a standard fluke meter that's showing about 4.8 volts. Checking our gauges, we're reading about 40 psi on the low side and right around 110 psi at the compressor discharge line. The transducer is being read by the scan tool up top. That's in the high pressure liquid line, and it's reading about 106 psi. So what we're going to do now is increase the heat load on this system and watch what changes take place on these meters. As the vehicle is set up right now in a low heat load condition, the windows are closed, the recirculation is turned on, and the blower motor is running in its lowest position. So to increase the heat load, we're going to open all the windows. We're going to turn it from recirculate to outside air, and we're going to turn the blower speed to its highest position. Right away we can see the high pressure side going up. At the compressor discharge we're climbing up pretty close to 150 now. And on the liquid line we've gone up to about 140. And they're both still climbing. The low side seems to be staying steady, although it looks like it might have dropped just a little bit. What's most noticeable is the change that the PCM is commanding to the compressor. The voltage is still climbing and has already reached 10.3 volts, which is about 83% duty cycle. But it looks like we're not done yet. So let's keep watching and see what happens. Well, that didn't take that long, only a couple minutes, and it looks like we've pretty much hit the top. The compressor is being commanded at 100% duty cycle, which is coming out to about 12.87, maybe 12.9 volts. There's been very little change to the low side. Looks like it's at about 41 psi. The compressor discharge high side has gone up even further and looks like it's sitting at about 165. Same thing with the transducer, which is reading the high side liquid line. That's gone up to about 152. So what we're going to do now is go back down to our low heat load condition. So we're going to turn the blower speed back down to low, close the windows, and change the setting from outside air to recirculate. So what appears to be happening is, as the heat load on the system is decreasing, during this time the PCM is actually turning off the signal to the compressor solenoid valve. You can hear a change in the tone in the engine and also see the fluke meter and the duty cycle meter drop all the way down to 0. But since there still is a call for cooling, the PCM has to turn the compressor back on at some point to keep the evaporator temperature at the set level. Well, it's taken a little bit longer to come back down, but we're pretty close to where we were when we started in the low heat load condition. We're right around 40% compressor duty cycle, about 4.7 volts on the fluke meter. We're still hovering right around 40 on the low side, and our high side pressure is right around 125. Even the transducer on the liquid line is reading 118.